Welcome back everyone. In the previous class, we were studying about the 5 layer of the IEEE standard 802.15.4. Let us study about the MAC layer of the same. The IEEE 802.15.4 MAC layer manages access to the 5 channel by defining how devices in the same area will share the frequencies allocated. The devices which are appearing in the same area, how they will share the frequencies which are allocated by the 802.15.4 MAC will be managed by the MAC layer. Scheduling and routing of data frames are coordinated. The 802.15.4 MAC layer performs the following tasks. So let us see what are the tasks performed by it. The MAC layer. Network beaconing for devices acting as coordinators. That means new devices use beacons to join an 802.15.4 network. So what is this beacon? Beacon means it will advertise that there is a network and a device can join. There is a coordinator. Network beaconing for devices acting as coordinators. The coordinators will beacon. The new devices where the network is existing will be offered to join to the 802.15.4 network. Then it also performs PAN association and disassociation by a device. PAN means personal area network. Any device can associate with PAN or it can disassociate it with the PAN. Then it also gives the security of the device and also reliable link communication between two peer MAC entities. That means between the two devices, the MAC entities, reliable communication will be assured by the MAC layer. The 4 types of MAC frames are specified in 802.15.4 to achieve these tasks. They are data frame, which handles all transfers of the data, the beacon frame, which is used in transmission of beacons from a PAN coordinator to tell the other devices that there is a network existing, there is a coordinator existing. Then the acknowledgement frame, which confirms the successful reception of the frame. So whenever there is a successful receiving of a frame, it will give the acknowledgement frame. So these are all the frames of MAC layer in 802.15.4. Then also MAC command frame, which is responsible for control communication between the devices. So these are the 4 different MAC frames which are specified in 802.15.4 to achieve the previous task which we have discussed. The MAC frame is carried as the 5 payload. So what is the MAC frame? We have seen in the previous class the 5 frame, right? So what are the different contents of the 5 frame? There was a frame controller, there was a payload and other frame starting point and all those things we have studied in the 5 frame. So let us see what are the contents of the MAC frame. The MAC frame forms the 5 payload. What do you mean by this? Let us see here. So this is what it means. This is the 5 frame we studied, right? So it has a preamble, it has a start of frame delimiter, it has a frame length and the PSDU, which is the actually payload. So now what is the MAC format, MAC frame format? So the PSDU itself is the MAC form. See, it is extending here. The PSDU full format is displayed here. So that itself is the MAC frame. So what are the contents of the MAC frame? Let us see. Here also it has a frame control, sequence number, destination PAN identifier, destination address, source PAN identifier, source address. So all these will make the MAC header, and these 4 bits, these 4 fields will make the addressing fields, which is 4 to 20 bytes, and the frame payload, it is the actual data which we are sending through the MAC frame. It is variable and 2 bytes frame check sequence, which is the MAC footer. We'll study all of them. What are they? So the MAC header field composed of, this is the MAC header field. It is composed of the frame controller, sequence number and the addressing fields. Addressing fields means destination ID, PAN ID, destination address, source PAN ID, source address. PAN means the network, personal area network. The frame control field. The frame control field means this field defines attributes such as the frame type, addressing modes and other control flags will be given in the frame control, which is of 2 bytes. The sequence number. So you can see in the previous slide, this is the sequence number. So that sequence number it is an identifier for the frame. So what is the number of the frame? What is the number of the packet? That will be specified by this sequence number. The addressing field specifies the source and destination PAN ID fields as well as the source and destination address fields. The MAC payload. The MAC payload is this field, the MAC payload. The MAC payload field varies by individual frame type. It is varied. For example, beacon frames or MAC command frames have different fields present. So this is an example. So likewise, the MAC payload will be different. The MAC footer. Here you can see this is the MAC footer. So the MAC footer field is nothing more than a frame check sequence. So it is just a checking sequence whether the packets are in a sequence or not. To check that, MAC footer field is useful. An FCS is used by receiving side to confirm the integrity of the data in the frame. FCS is used by receiving side to confirm the integrity of the data in the frame. FCS is the frames check sequence. It is used by receiving side to confirm the integrity, means authenticity of the data frame which is received. So next, coming to the topology. We have discussed it in the previous class. We will be studying about different aspects of all the IoT access technologies, that is the alliance, file layer, MAC layer, topology, security and compliance, different competitive technologies. So out of that we have covered the alliance, we have covered the file layer, we have covered the MAC layer. Now we are stepping it into topology. So let us see what is the topology followed by the standard IEEE 802.15.4. It is this standard-based networks can be built as star, peer-to-peer or mesh topologies. So any of these topologies it can use, either the star or the peer-to-peer or the mesh topologies it can use. Mesh networks tie together many nodes. So we have seen in the previous class how the mesh network look like. Every 802.15.4 PAN should be set up with a unique ID. So in the previous slide we saw that, right? Source PAN ID, destination PAN ID. So whenever there is a PAN, personal area network, a PAN ID, unique ID should be set up for it. All the nodes in the same 802.15.4 network should use the same PAN ID. For example, if we set up a personal area network with some devices, so all those devices, let us say 4-5 devices are there in that network, all those 4-5 devices should use that same PAN ID, which is a unique PAN ID, to work with that network. So here we can see the sample mesh network topology where the PAN ID is 1, as we discussed in the previous slide. Every PAN should have a unique ID. Here the PAN ID is 1. This is a mesh network and you can see here this one is a PAN coordinator. So here it is given, this color is a PAN coordinator, which is the main coordinator which will coordinate the other devices in the network. Then these are all devices which are existing in the mesh network are full functional devices, and these two are the reduced function devices. We have seen in the previous class that full function device means which are having the privilege to communicate with other full function devices and also can communicate with the reduced functional devices, but reduced functional device cannot communicate with any other reduced functional device, but they can only communicate with the full functional device. So that is the introduction of these nodes. So now this is a PAN coordinator which will coordinate all these devices. These are full functional devices and these two are the reduced functional device. A minimum of one FFT acting as a PAN coordinator. So PAN coordinator is also an FFT. Out of these FFTs, one of the FFT will be acting as a PAN coordinator, required to deliver services that allow other devices to associate and form a cell or PAN. That means, for example, if any other new device would like to get added to this network, this coordinator will make the necessary arrangements. So like any new device which would like to join to this network should use the PAN ID 1. A single PAN coordinator is identified for PAN ID 1. So for any PAN ID, there will be only one single PAN coordinator. FFT devices can communicate with any other devices, whereas RFD devices can communicate only with the FFT devices. This I have told you. Then coming to the security, that is about the topology. So let us discuss about the security in IEEE 802.15.4 specification. It uses advanced encryption standard AES, which you have already studied in your computer networks, AES algorithm with 128-bit key length as the base encryption algorithm for securing its data. So it is using AES algorithm with 128-bit key length as the base encryption algorithm for securing its data. AES in 802.15.4 validates the data sent by a message integrity code MIC, which is calculated for the entire frame using the same AES key that is used for the encryption. The data which is received will be validated by this MIC and it is calculated by the same key, which is 128-bit key, for its encryption. Enabling the security features for 802.15.4 changes the frame format slightly and consumes some of the payload. So let us see how it is done. It changes the frame format. So some of the security additional features are added, hence the frame format is changed. So let us see what changes happens for the frame format. Security enabled field in the frame control portion of the 802.15.4 is a single bit that is set to 1 for security. So here you can see the frame in the frame control bit, in the frame control bit, in the frame control field there is a bit which is called security enabled field, which is set to 1. If it is set to 1, it means that we have enabled the security. Once this bit is set, auxiliary security header field is created after the source address field by stealing some bytes of the payload. That means here you can see here after the source address, auxiliary security header, another additional field will be framed here by stealing some of the bytes of MAC payload. Okay, here it is taking some of the space of the MAC payload and an additional auxiliary security header will be framed. So when it will be framed, when there is a bit, what bit is that? That is a security enable field which is present in frame control. If it is set to 1, that means we have enabled the security. When it is set to 1, an additional field called auxiliary security header will be framed by taking some of the space which is there in the MAC payload. Once this bit is set, okay, that is done. Auxiliary security header is created. So here security enabled bit in the frame control is set to 1. This frame control. It is indicating that auxiliary security head of field is added to MAC frame. So that is about the security of 802.15.4 technology. So let us see competitive technologies. Which are the other competitive technologies are there which are competing with this technology? A competitive radio technology that is different in its phi and MAC layers is dash 7. So this is a competitive technology. Dash 7 was originally based on ISO 18007 standard and positioned for industrial communication. So this is for industrial communications, whereas 802.15.4 is more generic. It can be used for any kind of applications. Commonly employed in active radio frequency identification, that means RFID implementations. Dash 7 was used by US military forces for many years, mainly for logistics purposes. Active RFID utilizes radio waves generated by a battery powered tag on an object to enable the continuous tracking. So you know how RFID works. So RFID uses a radio wave which is generated by a battery powered tag on the object enable continuous tracking. That means we have seen in our library books the RFID tags are there in all the books, so it will be in continuous contact with a device which is maybe battery powered and producing radio waves, generating radio waves which will be accessed by the RFID, and it will be continuously in tracking. That book will be continuously in tracking in the library. If the book is not issued, then you will not be allowed to go outside the library. That is how the RFID works. So that is about the 802.15.4 technology. So now let us move on to the other technology, which is some other flavor of 802.15.4, which is 802.15.4G and 802.15.4E. The IEEE frequently makes amendments to core 802.15.4 specifications. That's why we have this G and E. It is making some amendments. Whenever it is necessary, some additional features to be added according to the contextual requirements, the amendments will be made before integrating them into next revision of the core specification. When these amendments are made, a lower case letter is appended, like as in a G and a E is appended. Similar way, any lowercase letter will be appended when a new amendment is made. Two such examples are 802.15.4E, which is 2012 version, and also G is also a 2012 version. Both of these amendments were integrated in IEEE 802.15.4, the 2015 version, but are often still referred to by their amendment names only. The IEEE 802.15.4E amendment of 11 version expands the MAC layer feature set to remedy the disadvantages associated with the previous version, which is 802.15.4. So what this E version is doing, it is making an amendment by expanding the MAC layer feature to take off the drawbacks which are there in the previous version, which is 802.15.4. So what are those disadvantages? The MAC reliability, unbounded latency, and multipath fading. So multipath fading means whenever a signal is reaching the device from different paths, the signal strength is weakened. That is multipath fading. So that was not taken care in 802.15.4, and also the reliability of the MAC and unbounded latency. That means the determinism. There was no threshold for the latency. So these drawbacks are addressed in 802.15.4e by expanding the MAC layer. 802.15.4e also made improvements to better cope with certain application domains such as factory and process automation. So some other improvements also made with E version for the application domains such as factory and process automation and also the smart grid. So what is the smart grid? It is an interesting feature. Added a video here. So let us watch this video to understand what is the smart grid.
It's easy to take electricity for granted, but modern life would not be possible without it. To keep it going, we need more efficient ways to manage electricity. This is the smart grid, explained by Commoncraft. For over 100 years, coal and other fossil fuels have been used by power plants to produce the electricity we use every day. The grid is a network of power lines and substations that carry electricity from power plants to homes and businesses. Today, the grid has problems. It needs updating and is running at capacity. When power lines break or power plants can't produce enough power, blackouts can occur, and that's a problem that can cause fatalities. At the same time, today's grid often relies on a single power source and doesn't provide detailed information on usage, making electricity difficult to manage. To address these problems in the past, we simply built new power plants. But now we can work towards sustainability and reduce our dependence on fossil fuels by using a smarter grid. Here's how. The smart grid means adding sensors and software to the existing grid that will give utilities and individuals new information that will help them understand and react to changes quickly. Let's say a tree falls on a power line and 1,000 homes lose power. With the current grid, utility employees often physically reroute power, which takes time. With the smart grid, sensors and software would detect and immediately route the power around the problem, limiting the issue to fewer homes. And there's more. The price of electricity changes throughout the day, but we can't see it with the current meters on our homes. It may be expensive during peak hours and cheap late at night. With new smart meters at your home, you could set your dishwasher to run when power is cheap. This provides more control of your energy bill and helps prevent blackouts at peak hours. The smart grid also means new ways to use renewable energy. Power generation can now be distributed across multiple sources, so the system is more stable and efficient. It's this ability to communicate and manage electricity that makes the grid smarter and helps us avoid burning more fossil fuels in the future. The smart grid is still a few years away, but soon we'll be able to manage our energy bill, help the environment, and help the economy by making more informed decisions about how we use electricity. I'm Lee Lefevre, and this has been the Smart Grid, explained by Commoncraft, in collaboration with the Energy Providers Coalition for Education. Learn more at EPCE on.
Okay, that is the information about the smart grid. IEEE 802.15.4e 12 version enhanced the IEEE 802.15.4 MAC layer capabilities in the following areas like frame format, security, determinism mechanism. The determinism means this unbounded latency. So when for any operation the latency should not cross the threshold. It should be the same. So that is determinism. So it has been improved, and also frequency hopping. The frequency hopping in the sense the frequency of the signal is distributed among different channels in order to get the efficiency of transmission. So that is frequency hopping. So IEEE 802.15.4e 12 version enhance the MAC layer capabilities in all these areas. So coming to 802.15.4g, which is 12 version, is also an amendment of 15.411 standard. Just like E version of 12, this G version of 12 is also integrated into 802.15.4 2015 specification. The focus of this G version of 802.15.4 version is the smart grid. So just now we saw what is a smart grid, right? So main focus of that is the smart grid. So G seeks to optimize large outdoor wireless mesh networks for field area networks. So it is concentrating on the field area networks because it is a smart grid and it is obviously implemented in the field area networks. New PHY definitions and MAC modifications are introduced. This technology applies to IoT use cases such as the following. So what are the application areas of this 802.15.4g is distribution, automation and industrial supervisory control and data acquisition. Supervisory control and data acquisition, in short it is called as SCADA. This will be studying in our upcoming discussions in other modules. Environments for remote monitoring and control. This is mainly for the industry. Then public lighting, image environmental, wireless sensors in smart cities, electrical vehicle charging stations, smart parking meters, microgrids and also renewable energy. So microgrid is another important version of smart grid. So I have given a hyperlink here also. Let us see a video to understand what is this microgrid.
With 60% of the human population set to be living in urban areas by 2030, and pressure on regional and national power grids continuing to grow, a number of cities are now turning towards localized energy production for new developments. As the name suggests, microgrids are small-scale electrical networks that operate independently or in tandem with large-scale electrical supplies. While many national and regional electrical grids are now powered in part by renewable energy, the majority still depend on nuclear and fossil fuels to deliver the bulk of their power. Conversely, microgrids make heavy use of renewables, such as photovoltaics and wind turbines, to generate energy for use within a specific building or development. This enables them to power their systems and operate without adding to the demands of the wider electrical network. On-site energy production and storage can enable a new development to become self-sufficient and help fill in the gaps that can arise on overstretched electrical grids. As part of their pledge to honour the 2016 Paris Agreement on climate change, cities around the world, including several in the United States, are passing legislation to make all new public buildings and developments emission-free. The use of microgrids can contribute significantly to achieving these requirements, whilst better insulating large urban areas from potential power failures or blackouts. Excess energy generated on small-scale systems can be stored on site for use at a later date, or be fed back into wider power grids when necessary. Whilst legislation is one step, private enterprise is also getting on board with microgrids and localized energy production. Pursuing clear environmental benefits and reduced operating costs, developers are beginning to integrate systems from forward-thinking manufacturers and technology entrepreneurs alike. One such manufacturer is Polysolar, a UK-based firm who have developed transparent photovoltaic glass. Their panels can be used to cover large areas without obstructing views and resemble conventional windows. Though currently emerging,
This system could be adapted to cover larger glass buildings in cities around the world, allowing them to generate much of their own electricity. On a more domestic scale, Elon Musk's Tesla solar roof integrates photovoltaics into conventional appearance roof tiles, turning entire surfaces into localized power generators. This system is integrated with the Tesla Powerwall, allowing excess energy to be stored and used throughout the year. Many large and small-scale developments are also now incorporating wind turbines to generate power and feed their microgrids, reducing their reliance on regional and national power networks. Energy market analysts Pike Research estimate that microgrid power generation has now increased five-fold from 2012 levels. And with an increasing array of innovations coming to market, we could see entire cities and urban areas powered very differently in the years ahead. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1M.
So that is about the microgrid.
I'm about to show you the quick.
So that is about the microgrid. Microgrid means the localized energy generation. What is the requirement of that local area will be generated then and there itself using the energy sources like solar or wind energy and utilized in that area. If excess amount of energy is also produced, then it can be given to some other applications also. So that is about the microgrid. Then let us see the standardization and alliance of these technologies. To guarantee interoperability, the WISUN alliance was formed. So you know interoperability. Interoperability means different platforms, different data formats, data and devices are working together, and there should be a corresponding flexible format or a platform should be available to work in coordination. So that is interoperability. In order to achieve interoperability in IoT networks, the WISUN alliance is formed. So what is this WISUN? Y stands for wireless, SUN stands for smart utility network. This organization is not standards body but is instead an industry alliance that defines communication profiles for smart utility and related networks. The WISUN Alliance performs the same function as the Wi-Fi Alliance and WiMAX Forum. Each of these organizations has an associated standards body as well as the commercial name. Let us see in this table the commercial names, industry organizations and the standard bodies. Wi-Fi, the industry organization is Wi-Fi Alliance and the standard body is IEEE 802.11 wireless LAN. The commercial name is WiMAX, industry organization is WiMAX Forum, and the standard body is IEEE 802.16 wireless MAN. WISUN, industry organization is WISUN Alliance, and IEEE standard body is IEEE 802.15.4G, which is our discussion now. Wireless SUN, SUN, SUN is Smart Utility Network. Then coming to the physical layer, the file layer. In IEEE 802.15.4G 2012 version, the original IEEE 802.15.4 maximum PSDU size is 127 bytes. This we have studied, right? In 802.15.4, the PSDU size maximum is 127 bytes. So now it is increased in the SUN 5 layer to 2047 bytes, so which is more than the MTU size of IPv6, right? The MTU size of IPv6 is 1280 bytes and the maximum PSDU size was 127 bytes. Now it is upgraded by SUN 5 to 2047 bytes, which is much more than the MTU size of IPv6. So in this view, fragmentation is not at all necessary at the link layer. When IPv6 packets are transmitted over IEEE 802.15.4G MAC frames. So when it need to be transferred, see, because in the previous class we studied that IPv6 MTU size is 1280, but the 802.15.4 PSTU size is 127. So this 802.15.4 packets need to be sent using IPv6. So this packet MTU size need to be fragmented and header to be compressed. That was done by the adaptation layer 6 LoRaWAN. But now as the Sun 5 increase the size of the MTU to 2047, so there is no necessary of fragmentation in the link layer. Also, the error protection was improved in IEEE 802.15.4G by evolving the CRC, cyclic redundancy code, from 16 bits to 32 bits. Data must be modulated onto frequency using at least one of the following 5 mechanisms. In the previous standard also we had studied many modulation techniques which are applied in 5 layer. Here also we have some mechanisms to modulate the frequency in the 5 layer. They are multi-rate and multi-regional frequency shift keying, which offers good transmit power efficiency due to constant envelope of transmit signal. The other one is the multi-rate and multi-regional orthogonal frequency division multiplexing, MROFDM, provides higher data rates but too complex for low cost and low power devices. But if higher data rates are necessary, this modulation technique may be used. Then the next one is multi-rate and multi-regional offset quadrature phase shift keying, which makes multi-mode systems more cost effective and easier to design. So that is about the 5 layer. Let us see the details of MAC layer. The following are some of the main enhancements to the MAC layer proposed by IEEE 802.15.4E 2012 version. These are the enhancements done. What is the first enhancement is time slotted channel hopping, which is in short TSCH. TSCH divides time into fixed time periods or time slots, which offer a guaranteed bandwidth and predictable latency. In a time slot, one packet and its acknowledgement both can be transmitted, increasing network capacity. So in a single packet, you can transmit both the data as well as the acknowledgement packet. So you can increase the capacity of the network, thereby avoiding the network traffic. The next enhancement is the information elements. In short, IEs allow for the exchange of information at the MAC layer either as header IE, which is a standardized one, or payload IE. So header information elements and payload information element. Header information is a standardized one and payload information element is a private one, specified in a tag length value format, TLV. TLV, T stands for tag, L stands for length, and V stands for value format. So this is the format of the information element. IE field allows frames to carry additional metadata to support MAC layer services. So this IE is able to carry some additional metadata to provide some MAC layer services. The next enhancement is the enhanced beacons, EBs. So EBs extend the flexibility of IEEE 802.15.4 beacons to allow the construction of application specific beacon content. So application specific, for which application the network is constructed, for that application the beacons will be the beacon should be constructed. So that is enhanced beacons. This is accomplished by including relevant information elements in enhanced beacon frames. So how it is possible to construct the application specific beacon is by including the IEs in EB frames. Some of the information elements that may be found in Enhanced beacons include network metrics, frequency hopping, broadcast schedule, and PAN information version. So these are the contents of the information elements. The metrics of the network and the frequency hopping, broadcast schedule. So how the frequency should be distributed among different channels, and also the PAN information version. So what version of PAN we are using? What is the idea of the PAN? Then enhanced beacon requests. So how the beacon requests are enhanced. Like enhanced beacon requests also leverages the information elements only. The information elements in enhanced beacon requests allow sender to selectively specify the request information. So selectively the sender can specify the request information. Beacon responses are then limited to what was requested in EBR. For example, a device can query for a PAN that is allowing new devices to join, or a PAN that supports a certain set of MAC or PHY capabilities. The next enhancement is the acknowledgement enhancement. The enhanced acknowledgement frame allows the integration of frame counter for frame being acknowledged. So there will be an attachment of a frame counter for the frame which is acknowledged, for which frame the acknowledgement is sent. So that frame counter is attached. This feature helps protect against certain attacks that occur when acknowledgement frames are spoofed. So in between, if intruder attacks and the acknowledgement packet fails to reach the receiver, so then next acknowledgement may not be known to which frame it is sent. So acknowledgement frame, if it is attached with a frame counter, that is the number, then it will be helpful for understanding which acknowledgement is for which frame. So let us see the MAC frame format for 802.15.4G as well as E. 802.15.4G 2012 version 5 is similar to 802.15.45. It is very similar to that. The main difference is that the payload size. The rest of the things are same. There is a frame control, sequence number, addressing field, frame payload, and the MAC footer. So those are all the same. But the thing is, the difference is that there are IEs also and auxiliary security headers. But the payload size is different. That means earlier in 802.15.4 the payload size was 127 bytes, but now it is upgraded to 2047 bytes. So that is the change what we have in the MAC of 802.15.4 G bar E. The auxiliary security header provides for encryption of the data frame. So here auxiliary security header, we have seen that there is a bit in the frame control to enable the security bit. If that bit is set to 1, the auxiliary security header will be added, which will provide the security for the header and encryption for the data frame. The IE field contains one or more information elements that allow additional information to be exchanged at the MAC layer. Then the topology. So what topology we use in case of the 802.15.4G 2012 version. The most deployment of 802.15.4G version is using the mesh topology, because as it is the best choice for use cases in the industrial and smart city areas. So these are the utilities, right? Major utilities of the 802.15.4 industry and smart utility. So the mesh topology is best suited for the industries and the smart cities. Hence the mesh topology is mostly deployed used topology for 802.15.4G 2012 version. Then the security. Encryption is provided as usual as the previous standard by AES algorithm with 128-bit key. And MIC is a unique value. See this MIC, which is message integrity code. MIC stands for message integrity code, is a unique value that is calculated based on the frame contents. So the based on this frame content, MIC is calculated. So that is another security feature. So which can be evaluated at the sender and the receiver side for security. Then the competitive technologies for 802.15.4G. The competitive technologies for G and E parallel the technologies that also compete with 802.15.4. That means the competitive technologies for this G and E version of the 802.15.4 standard is the same as the competitive technology which was for 802.15.4, such as dash 7, right? Dash 7 we have seen in the competitive technology of 802.15.4. This is also a competitive technology for G and E version 2. 802.15.4 and its various flavors of upper layer protocols can be seen as competitors as well. That means the flavors of 802.15.4. So we studied some of the technologies which uses this standard, right? Those are Zigbee IP, 6LoWPAN, Thread, and others. Some list of technologies we studied which uses this standard, right? All of those flavors, all of those protocols are also the competitive technologies for this G and E version of 802.15.4. IEEE 802.15.4 is well established and already deployed in many scenarios, mostly indoors. So it is majorly used for indoor applications. Okay, so let us stop for today because we are starting with a new technology, new IoT access technology in the next slide. So let us wind up here for today. Let us discuss the rest of the things in the next class. Bye. Have a good day.